Hi, we continue our lesson in topic of electromagnetic induction. That is part 2, application of electromagnetic induction. So for the application of electromagnetic induction, we are going to discuss about generator. That is current generator. Current generator functions by converting mechanical energy to electrical energy. This one we have discussed before. By relative motion, produce changing in magnetic field, thus produce electric current or induced current. Current generator works based on electromagnetic induction and uses the Fleming's right-hand rule. I hope you still remember, we have discussed before Fleming's right-hand rule. Current generator is divided into direct current generator or DC generator and alternate current generator or AC generator. Look at the first one, direct current generator. So this is the diagram that shows we have coil or wire, okay, and this is the magnet or permanent magnet, north pole and south pole. So you can see the coil or wire is connected to a commutator. The commutator, also known as a split ring commutator. Split ring commutator. Okay, so this one you can see half of the part of the ring is connected to a carbon brush, left and right. Okay, and this one connected to, you can see we can put here a galvanometer or a bulb, okay, just to have a complete external circuit here. Okay, now how it works. What is the function of commutator or the split ring commutator? So the commutator function reverses the connection of the coil with the external circuit every half cycle. Half cycle means 180 degrees of rotation. So that's the current in the outside circuit always flows in the same direction. Okay, so we'll discuss more on this. You can refer to the next page, page 78. Okay, now we want to describe how does a DC generator work. Show the direction of movement of coil AB and CD. Mark direction of induced current in the coil and the galvanometer. So this is the galvanometer, zero-centered galvanometer. So initially here we can say this is a 0 degrees of rotation, initial position. Okay, so you can look at here, the U here means is north pole, north, utara, and here south, selatan, north or south. Here north, utara, and here is south, selatan. So the coil we mark as A, B, C, D. So meaning there is a magnet here, there is a permanent magnet here. Okay, so this is a commutator. You can see one of the part is blackened. This one is a blackened color. Okay, let's say we rotate the coil anti-clockwise direction. When we rotate coil anti-clockwise direction, meaning force of motion on AB is downward. Force of motion on CD is upward. So thus it will rotate in anti-clockwise direction. Okay, so you can say coil AB move downward, coil CD move upward. So you can write down or fill in the blank here. Downward, coil CD move upward. Okay, so when the coil rotates, its side cut across magnetic field. As you can see, we have a permanent magnet here. There is a magnetic field lines. So meaning once the coil rotates, it will cut the magnetic field lines. And induced current flows in the coil from which direction? So here you must apply Fleming right-hand rule. So in this case, you can see for part AB, the force downward, when the force is downward and direction of the magnetic field is to the right, south, so you can see the current is flowing out, meaning direction of B to A for side AB. So you can mark a direction of current here. For side AB, current is flowing out. So side CD, current is flowing in, because this is a one coil. So if we continue to mark direction in the external circuit, this part, okay, so direction of current is in direction of DCBA. Okay, DCBA. DCBA. Okay, DCBA, DCBA. So we continue to mark here, so it will go like this, from left to right. So from left to right, the pointer will deflect to right. Okay, so galvanometer will deflect to right. Okay, so this is the first initial position. Okay, now continue rotate the coil. So this one rotation 90 degrees. So the coil is vertical. So meaning the force that act for side AB is to the right, for CD is to the left, and this is the north pole and south pole of the magnet. So meaning now the direction of motion of the coil is parallel to the magnetic field of permanent magnet. When the direction of motion is parallel to the magnetic field of permanent magnet, there will be no cutting, cannot cut. Okay, so when this happens, no cutting off the magnetic field, meaning no change in magnetic flux. So when no change in magnetic flux, meaning no induced current. Okay, so when no induced current means external circuit will show no reading. At the same time also you can see the commutator is no longer in contact with the carbon brush, meaning the external circuit is also broken. Okay, so when this happens, we have the reading equals to 0, no deflection, zero-centered galvanometer. So here is 0 reading. So the side AB and CD are moving parallel, okay, to the magnetic field, and thus do not cut the magnetic field lines. No induced current. Is produced at the instant the galvanometer returns to 0 mark. No reading. Okay, next. Let's say we continue to rotate until 180 degrees of rotation. So you can see the coil become horizontal again. Okay, so now the position of the side AB and CD now is already changed. This side becomes CD and this side becomes AB because it's 180 degrees of rotation. So this is the magnet, north, south. Okay, so we continue to rotate in anti-clockwise direction. So this is the force that acts for side AB, and this is the force that acts for side CD, because it rotates in anti-clockwise. Okay, now apply Fleming right hand rule. So you can see for side CD, direction of current is flowing out. For AB is flowing in, because it's in one coil. Okay, so if you see the commutator, the blackened part already changed position. Okay, because of 180 degrees of rotation. Okay, we continue to mark in the external circuit. So we get left to right, so meaning deflect to right. Okay, so we get this, so deflect to right. Okay, now as the coil continues to rotate, current will again be induced in the coil, but its direction is now opposite to that in figure 1, which is from where? Figure 1 is from A to B, and from C to D, or we can say in the direction of A, B, C, D. So you compare the first part here, for 0 degrees rotation is DCBA. Now it becomes ABCD. So we can see here, direction of current is already reversed for half of rotation. So however, direction of current through the external circuit remains the same. So galvanometer deflects to right. So you can see here for the first part here, deflect to right, here also deflect to right. Even the direction of current in the coil is already reversed, but the current that induced, that passed through the galvanometer, still in the same direction. Okay, so now continue until 270 degrees, become vertical again. So direction of force or motion here, this is north pole. So side AB are moving parallel, thus do not cut the magnetic field line, no induced current. Is produced, the galvanometer returns to 0 mark. So the process is repeated. Meaning in order to produce more current, induce current continuously, so you need to rotate the coil continuously also. Okay, so in this case you can see the current that produced in the same direction. That's the reason why we call this generator as direct current generator. It produces direct current. Okay, so produce direct current. Okay, we look at the graph to show current that produced, to prove that the current produced is direct current. So the induced current varies from maximum to 0. It flows in one direction only, hence the induced current is called direct current. So you can see here the vertical part current is 0. The horizontal part, current is maximum because force and the magnetic field are perpendicular to each other. Cutting is maximum here. Okay, so here vertical 0, and here horizontal again, still in the same direction, so it's maximum. Thus we get this graph. Okay, so this one is graph for DC generator. Okay, let's look at AC generator. What is the difference between DC generator? Same thing, has a coil that connect to. Now we don't use commutator anymore, we use slip rings. Okay, slip rings. There are 2 rings. Okay, here is north and here is south. Let's say we still rotate in the anti-clockwise direction. The 2 ends of the coil are connected to 2 slip rings which rotate with the coil. Each slip ring is always in contact with the same carbon brush. So meaning the part here, the ring, keep rotating and it's always connect to the carbon brush. Okay. Okay, we discuss one by one the working principle. So this is north. Okay, we rotate anti-clockwise. 0 degrees of rotation. So you can see the side AB is connect to the first ring, CD connect to the second ring here. Okay, so we have a ring P and ring Q. Okay, so or you can mark the carbon brush also can. Okay, now let's say it's anti-clockwise direction, meaning motion of CD is upward or force is upward. Here is downward. So you apply Fleming right hand rule, you will get direction of current here, AB is out, direction of CD is in. This is one coil. Okay, so we continue to mark direction here. Okay, so you will get you will go to P, meaning from P to Q. So from P to Q, we look at this side, it will rotate to the right. Okay, to the right. Yeah? So coil AB move downward. Down is okay, no? And move up. Okay. When the coil rotates, its side cut across magnetic field lines and induced current flows in the coil from which direction? D to C, B to A. Okay. D to C, B to A. So this one we apply Fleming right hand rule to determine direction of current. In the external circuit, current flows to from where? P to Q. So we have deflection this direction. Okay. Okay, now rotate 90 degrees. So this is direction of the motion for both sides. This is north pole. Okay, so side AB and CD are moving parallel. Parallel means cannot cut. Okay, like you use knife to cut thing, you must place at any angle. Maximum is 90 degrees. If parallel, you are not able to cut things with the magnetic field and does not cut. Does not cut magnetic field lines. No induced current. Is produced at the instant. So the zero mark return to zero mark, the reading. Okay, let's say I just put like this. Center no zero, no reading, zero. Okay. Okay, this one 180 degrees of rotation. So this is direction of force here, at upward, here, downward. Okay, so it's anti-clockwise direction. Here is north. Okay. After the vertical position, the current increases until it attains maximum value and the coil in horizontal position. Coil CD move down and coil AB move up. Direction of induced current is from where? Okay, now we apply Fleming right hand. So CD is out, AB is in. Okay, so if you continue to mark from CD, remember CD connect to the second ring. So now current go to the second ring first. Okay, go here and then only go to AB. Okay, you must make sure you understand how it connect. The CD just connect to the second ring, AB connect to the first ring. So this direction, meaning is right to left. Okay, so it will deflect to left. Okay, so direction of induced current is from A to B and then C to D. Okay, so direction of current through the external circuit is from where? Q to P. Okay, Q to P. Okay, second one, rotate another 90 degrees, so it becomes 270 degrees, become vertical. So force or motion, this is North Pole. Okay, side AB are moving, AB and CD parallel to the magnetic field lines, so do not cut the magnetic field lines. No induced current. The galvanometer returns to 0 mark. Process repeated. Okay, so now you want to mark here no reading, so return to 0 mark. Okay, now what I want you all to see here is from the initial position, 0 degrees Celsius, direction of current is to the right. After half cycle of rotation, 180 degrees, it becomes opposite direction. See, for this type of current that flows in the opposite direction every half cycle, we call it alternating current. That's the reason we call it AC generator, because it produces alternating current. Okay, let's look at the graph. Okay, here you can fill in Q to P yourself. Okay, so this is the graph. This is vertical position, 0 reading. Horizontal, maximum cutting, so you have maximum of induced current. Vertical, 0. After half rotation, the current reverse direction, so you put here down. Okay, and then 0 again. So we get this kind of graph. There is every half cycle direction of current is reverse, so we call it AC current. So the output current generator is an alternating current because current changes direction in the external circuit each time the coil passes vertical position, meaning every half cycle or every half rotation. Okay, assume the current flows from P to Q is positive and the current flows from Q to P is negative. The current changes magnitude and direction after every half rotation. So you can see the angle also take into account. So maximum angle is right angle 90 degrees, so we have maximum cutting. So when the angle starts to increase, you can see the number of lines being cut also increase. That's the reason why the current number of or magnitude of current increases until maximum when horizontal position is. Okay. So I think that's all for the application. We continue in the AC.